this web application works. The logo up here will always give us, behave like our start button. So if you would want to use it, first of all, you need to know what's the work of the logo link. So the logo will always take you back home every time you're using your Tinkercad. Then within home, you'll have classes, design, collection, tutorials, and other challenges that are within this particular web application. So in most cases, we are going to use circuits. So for that to happen, you just have to go to the word create, and then you pick on the circuits. So in most cases, we will be creating several circuits using available components on this Tinkercad. So this Tinkercad has tools. It has a toolbar. We have a toolbar up here. So I've said the logo Tinkercad here behaves more so like our start button. We have components on this other side. We have the ordinary design view. So once we have implemented whatever that we want to design, we have the code view here. So you'd want to have your code, then your code will go in here. Once you finish it, then you'll have to simulate. So whatever you want to simulate for you to start and stop here. You'd also want to send it maybe to other people. You want to share it with your group, whatever you've worked on. Then you use the share button, which is basically sitting at the end here. Below here, we have the basic tools, but you can pick all the tools. All the tools are available here. Quite a number of tools are here. So all these tools, you actually learn how to use that. You have the search button. You can be able to search a specific tool that you want. At the same time, we have the Arduino boards, several types of Arduino boards. It depends which kind of board you want to pull out. We have, so to start, that is what we have. And we are going to see how do we utilize all these available components. One of the disadvantages of this simulator is that it does not have all the components. So that should also come very clear that we are not in a position to have access to all the components. But as we move forward, we'll be able to see what are the areas in which we can use this and which are the areas in which we cannot use this. So how do we design our Arduino, or how do we design our components on this particular simulator? So whatever the name of the simulator that you'd want to have, the name will go up here. So the best way of renaming this, I just click on the existing name up there. I'll remove what is there. Then I'll call it maybe LED indicator. So then I press enter. So I'll be able to rename my project. So the best way of renaming your project, I've said just double click on this up here, and you'll be able to give your project a name. The other thing is, when I want to use any tool, I would want to pick it on this list. So for example, for us to begin, the first thing that we'll need to pick is an Arduino board. So basically that is what I want. So there are scenarios whereby you'll have several Arduino boards in one setup. Depends on what you're trying to implement. But by default, it will give it a name up here. But you're also free to rename it. And with this, you can be able to hold on your component and put it in any position that you want. So for example, I just need to push it up there. Then I put my pointer on it, hold down my button, then I'll be able to put my board where I'd want it to go. So from our very last class, we did indicate that we did see how Arduino board looks like. We said that the Arduino board has pins and you can be able to see those pins, all of them here, both the analog and the digital pins. We have the power pins coming down here, and we have our microcontroller here, which we did indicate that our microcontroller is basically a 28-port chipset that you can actually reprogram. And remember giving you a small assignment that you'd be able to check what is the function of each and every pin. The reason why I think it's very important to know the function of each and every pin here, because if you look at the Arduino, how do we call them? There are other versions of Arduino that basically almost only does not have all these other components. What it has is only kind of a chipset like this one only. And with this chipset, then you'll be able to know. As we talk about these pins up here, we are talking about the subsequent pins on this particular microcontroller. So when you're speaking about these pins, or when you're configuring these pins, remember, this is what you are controlling. This is what you are configuring. So if you look at the Arduino Nano, like the Arduino Nano versions, it does not come with all this thing. It's just a small board around this microcontroller with a small, how do you call it? C port, or what we call type C port on it that you'd be able to use to power. But this one, you see, we use the ordinary Arduino, the standard USB port that we're using it because it's a bit bigger. But if you look at the Nanos, the Arduino Nanos, I don't know whether they have already been here. Just see if we have them. It's like we don't have Nanos on this. We do not have Nanos. But you can look around and see how Arduino Nano versions look like, and you'll realize that the Nano versions, or the Nano type of Arduino, this is Arduino Uno, but when you talk about Arduino Nano as the other versions of the boards, then you'll realize that it's a different type of components altogether. So as you learn more about embedded systems, you'll come across several types of these boards that will be able to help you implement a working IoT or a control device that will be able to help you create or develop different projects. So we talked much about this board, and that one to you now, you're okay. The other thing now it comes in is what we call a breadboard. A breadboard is very fundamental to us because this is whereby we will be able to put all our components. So the breadboards are very fundamentals, and they help us to link our components with our board. We not put components like the LED lights here. I cannot take and say, now I want to put my LED light directly on my chip like this one. This is not right, because assume I would want to have several of these LED lights, then I'll not have enough ports to be able to slot them. So we would always want to use what we call a breadboard here, which will allow us to put several of these, like for example, the LED lights. So we should actually understand when do we use a board and when do we slot directly on our Arduino microcontroller. The other thing now, we have already seen two components. We have seen the Arduino board itself. We have also seen the other component called a board, breadboard. There are other components. So like in this scenario, you can see for us to have this working, then we have to power it using what we call the USB port. And from our last class, what did we say about the USB port? It can give us a voltage of how much to the board? Anyone who can remember the power voltage that the USB can provide to the board?
5 volts.
5 volts, good. So we did indicate that it's only a maximum of 5 volts that can be provided by the USB port. So you have to be very careful that what am I using in terms of powering my my board. So if I'm using the USB, then basically I'm using have a you should be able to have this. But what about if the power for my jack is not sufficient? Assume I only had a jack that can supply 9 volts. What if I have a component that needs maybe, let's talk about 20 volts? What happens in that scenario?
You can use the VIN.
You can use the VIN. Good. So this is where the VIN comes in. So the VIN port down here would be able to give us more voltage into this particular device. So if I do want to have a device that would consume more power and it cannot be supplied using my jack and it cannot be supplied using my USB, then I would use the VIN port to be able to feed in that power. And with the ground here, then I think you'll have enough power that all the components on your circuit would operate without a problem. So fair enough. So the other thing that now we need to know is that if I would want to have my, for example, I would want to ensure that this LED light goes on. The first thing that I need is I pick the LED component and maybe I can put it somewhere on this board. So from your digital electronic class, and I believe you learned about breadboard. Breadboard is not new in this particular class. So the breadboards, you should be able to know how actually the wires will run, because you can see up here I have a positive and I have a negative. So what happens is that the positive line, if I connect my wire here, then this particular wire will be able to power the entire length up to the end. If I put a wire here, then this wire will be able to power the entire length on this particular board. So for example, how do I put my wires? So my wires are this way, correct? I said this is just maybe a toolbar. So I would pick a wire there. I put it on port 7, D7. Then I would want to bring it up there. I click and I come this way. Then I would be able to click. Where do I want to put it? I want to put it somewhere here. Come down. So I have something like that, and I can change that color, can give it red, because that will be my positive power. So I can be able to do that. Then the other thing basically I can do is, because this is basically, I would want to send power over this particular wire at the same time pass signal, then I would be able to go back here, pick another wire. This time round, I would want to pass a ground wire, and my ground wire will be which power? My ground wire will be negative power. So click on it. And basically I can change that, come back this way, and can be able to change it to black. So with that, then you'll realize that if I have the whole of that line having the ground power and I have the whole of that line having positive power. So that is basically how to link your breadboard with this particular microcontroller. Then the other thing maybe now you can pick is, for example, I have an LED light. I would want to put it anywhere between A up to J. So just because of consistency, I would want to put anywhere along this line. So I can put it on maybe on A, and there we go. So once I do that, then the next thing that I need to do is to ensure that this particular line is also powered. Or the best thing, maybe I can use the upper part just to reduce the amount of cables that I want to run around here. Let me put it somewhere here at maybe pin number 10. Yeah, I can keep it there. Then the next thing I can do, I can grab another wire here, then maybe connect anywhere along this line, because all that will have power. Maybe I can put it there, then put it on this particular length. I can give it another color just to ensure that we have a good representation. Or let me just give it red, just to be sure that it is the positive power. Then on my negative line, I would also go back there, pick on a different color, just the normal black. I would want to have it going into, that is my positive line.